Alright, so you're welcome to the continuation of our class on Surds. And in this class, we'll be looking at the properties of Surds. We started in the previous class, and we took only the first property, that was multiplication of Surds. Alright, so let's continue. Multiplication of Surds. And there is something that I want us to understand about the multiplication of Surds. And we can have two surds. For instance, let us say we can have surd A, and then let's say times, and we can have another surd, let's say surd B. Alright, and what this simply means is that we can go ahead to multiply these two surds. We can multiply them together, and if you multiply them together, no matter what we had in that surd, we're gonna have an answer, and that will be surd AB. That will be surd AB. So for the multiplication of surd, you can multiply them directly together. Multiplication of surd, you can multiply them directly together. Okay, so you have a surd A, and then you have to multiply with the surd B. Just go ahead and multiply the both together, and you're gonna have surd AB. Now let's look at the division. Let's look at division of surds. For division of surd, for instance, let's have surd A. Okay, let's have surd A, still surd A this time, and then we have to divide it with the surd B. Okay, then yes, when we have these two surds like this, can just go ahead to divide them together and take the square root. Yeah, so what we're gonna have in this case will be equal to, now it's so simple, you're gonna have it as equal to square root of both A and B. That's what you're gonna have, square root of both A and B. So that will be the answer. Yeah, you're just gonna have square roots of both A and B. Alright, let's look at addition and subtraction of surd. When it comes to addition and subtraction of surd, there are some interesting things that we will need to consider. Okay, now the first, what we need to know is that let's have this surd A. So we could have surd A, okay, plus surd, okay, it's my plus, right, plus surd B. And there's something I want us to know, that this is not, okay, this is not equal to you just have everything together, and now you now take the square root of, you just have A minus B. No, it's not equal to this. You cannot, just like as we did for multiplication, we can multiply it together, but in addition, you cannot directly add. This is addition, please. You cannot add them together like this. No, you cannot. That would be wrong. And also, assuming it was subtraction, and we have let's say surd. Let's use surd A. We have surd A. and then you have to subtract it from sort B. All right, you cannot, this cannot be equal to, also this cannot be equal to, you now have everything together, and you now have it as everything in square root, right? Everything in square root, and you now have it as a minus b. No, this is not correct. Now have it at a minus b. No, that's not correct. It's not correct. So when they are different, this is b, this is b, it is not a minus a. Okay, this is a minus b. Let's have this as b, please. All right, so when the sorts are different, you cannot subtract them together. When they are different, you cannot add them together. Let's understand that. But when if the sorts are different for multiplication, you can go ahead to multiply them, and if they are different in subtraction, you can just go ahead and in the division, you can just go ahead and subtract. But in addition and subtraction, no. Now some certain things that we look at in simplification, in simplifying sorts. For simplifying sorts, we can have a sort like square root of 50, for instance. And we can have square root of 50, for instance. Now, what we need to know here is that a sort can be broken down to simpler form. It can be broken down to simpler form. No, it can be simplified by breaking it down to simpler form. So to break down this 50 into simpler forms, we need to think of two numbers that if we multiply, we can have 50, and one of them should be a perfect square. Okay, that one of them should be a perfect square. By now you understand what I mean by perfect square. Perfect square. All right, so we know that 50 is 25 times 2, right? Yes, 25 times 2. All of it is in square root, so all of it is in square root. And this also can be written as square root of 25 times, oh god, can have it as square root of 25, okay, times square root of 2, times square root of 2. Okay, and we know that square root of 25 is what? Square root of 25 is 5, and then we can now say times square root of 2. We don't have it, so we just keep it still as square root of 2, and the answer here will become 5 root 2. All right, 5 root 2. So we can simplify our sorts by breaking it down into small units. We have 50 here, so look for a perfect square that you can multiply with a number to have that 50, find the square root, and that is it. So these are some of the common properties of sorts. Then there's something I want us to see, and that will be when we talk about what we call rationalization of sorts. Okay, so when it comes to rationalization of sorts, there's something I want you to understand, that rationalization here simply means the removal of sort from the denominator. The removal of sorts from the denominator. We can have a number, let's say we have a number like 5, number like 5 over the square root of 2. Okay, now you look at this denominator here, we have a sort, and we want to remove it, because anytime we have something like when we are solving for the problem and you have your answer in this form, it is good and advisable to take away this sort here as a denominator. And to take away this sword as the denominator, what we simply need to do will be for us to multiply the denominator with the numerator again, and then with the denominator. Now this is what I mean. You have your 5 here, right? And then all over your sword that you had initially. Good. Now to take away this sword, because that's what we want to do, rationalization, you multiply the numerator here with the sword as a root 2, and also you multiply same denominator with the root 2 still with it itself, and you're gonna have your answer. Now okay, remember this, we did this 5 times root 2, just saying 5 root 2, okay, just saying 5 root 2, and then all over. Now square root of a number multiplied by square root of a number is that number without the square root. Okay, because take for example, we had something like take for example, we had, let's do this together. Take for example, we had something like the square root of 9, okay, times square root of 9. All right, and we know that square root of 9 is what? Is 3, right? And then so it means 3 times 3, and 3 times 3 is what? 3 times 3 is 9. So square root of, let's have 16, okay, times the square root of 16. So we know that square root of 16 is 4, and times another 4, and that gives us 16. So even though we have something like a square root of 5, in which is not a perfect square, that we have to multiply it with another square root of 5, multiplying together. We don't know the square root of 5, and we don't know, but since we know that square root of a number times square root of a number is that number as proven in this and this, so it means that square root of 5 times square root of 5 will also be equal to 5. All right, so of course here is 2, here is 2. Now this works for single swords. Now there's another pattern we need to do. If we can have something like a compound. Remember the type of sword I talked about? You can have a compound sword, and let's have, for example, a compound sword like 3 all over 2 plus. All right, this is now a compound sword. Yeah, 2 plus root 3. 2 plus root 3. And we are to rationalize, meaning take away the square root from the denominator. Now if you observe these 2 plus root 3, they are together, so it will not be a correct thing for us to do something like, you know, as we did the previous one by saying 3 times root 3. No, you cannot say 3 times root 3, because root 3 here is not alone, rather root 3 is with the whole of this. All right, so there's something that we need to do. There's something that we need to do to be able to remove the sword from that denominator. Okay, for us to solve this, there's something I want to introduce to us, and that is called conjugate of swords. Conjugate of swords. And when we are talking about this conjugate of swords, there is something it's very important, because we use conjugate of swords to be able to rationalize some compound swords like this. Okay, now what's conjugate of swords? So conjugate of swords is just for us to rewriting the compound sword, but this time around we are rewriting it with a different sign. Now, this is what I mean. This is a compound sort, right? The denominator 2. Let's have it here. 2 plus, okay, this plus. Now, square root of 3. This is a compound sort. And we need the conjugate of this. The conjugate of this is us writing this, but this time around with the opposite of this sign. We are particular about this sign. The opposite of plus is what? Is minus. So now we're going to write it as 2 minus square root of 3. So that will be the conjugate. Okay, what if we have something like the conjugate of 5 minus root 2? If we had this, what will be the conjugate this time around? What will be the conjugate? This is a compound sort, right? It's a compound sort. What will be the conjugate of this sort? Simple. It's going to be us rewriting this compound sort, but with the opposite of this sign. The opposite of this sign now will be what? Will be plus. So we rewrite it with the opposite of the sign. Now that will be 5 minus now plus plus square root of 2. So that will be our conjugate. So don't forget conjugate. We write the compound sort, but when you are rewriting it, rewrite it with the opposite sign. If it was plus, change to minus, or change it to minus. If it was minus, change it to plus. So let's use that here to be able to solve for this hours, to be able to rationalize this here. So now we're gonna have 3, and then all over the first sort, the first one here, 2 plus, all right, 2 plus here, square root of 3. Now, just like we did for the single one, multiplying with this sort that we have in the denominator, we're going to multiply it, but this time around we are multiplying it with the conjugate. And what's the conjugate? The conjugate is 2, in this case will be minus square root of 3, and also times 2 minus square root of 3. So that is it. Everything here, all right, remains like that. Now solving this, let's solve this out. Of course, multiplication, 3 times 2. Then we have here minus the square root. Okay, so we solve this out. This is, we multiply, use 3 to multiply everything there. So we now have 3 times this 2, that will be 6. Then the minus sign will come up, minus, then all right, the square root of that 3. We're done with the numerator. Now moving to the denominator, watch out what is going to happen in the denominator. Now these two here, we multiply this other 2. It's taking care of the 2, and the square root is multiplying the square root. Note that the 2 multiplies the 2, the number, the whole number goes to the whole number, the square root goes to the square root. That's how the multiplication will go in this case. All right, so 2 times 2 here is what? Is 4, and then the sign is minus. Okay, and then square root of 3 times square root of 3 becomes 3. Good. Okay, so having our answer, we can have our answer to be that the numerator remains. 6 minus square root of 3. It remains. Okay, and subtracted 4 minus 3 is 1. So this is the same thing as saying 6 minus square root of 3. Now we've been able to take away the sort. That is the essence of rationalization, taking away the sort that was given at any time. So we've been able to see the properties of sort, the multiplication of sort, division of surd, addition and subtraction, adding and subtracting surd, and simplifying. So then we went ahead to look at the rationalization of surd. So we'll be taking some examples with this, delving into past question for our examples. So both JAMB, past questions, WAEC, NECO, and the rest. Okay, so catch you in the next class. Bye-bye.